Over these next few lessons, we're going to look at interactively selecting components based on their orientation, or in other words, based on their normal direction. When we're working with higher resolution and more complex geometry, being able to select components based on their orientation can be a real time saver. For example, I've got a simple pyramid form here, but when I display the shaded wireframe, we see that each face of the pyramid is actually composed of a number of individual primitives. So if we wanted to select one of the sides of the pyramid, it's made a bit more difficult by having this level of resolution. I could orbit my view to something like this. And now if I enable the Select Fully Contained Geometry Only option, I could box select all the primitives on this side of the primitive like this. Or I could select all the primitives on the boundary of this side by holding down Shift and the A key and then clicking in each corner. And now I could hold down Shift and the H key to flood fill select all the primitives contained within the selection boundary. Both of these techniques work, but there is a quicker and easier way. What all the primitives on each side of the pyramid have in common is that they all face in the same direction, or in other words, they all have the same normal. And so we can use this commonality as a way of selecting them with the Select by Normal mode. We enable the Select by Normal mode using this button here in the Operation Control toolbar. And now with this enabled, I can simply click on one of the primitives and we see that that selects all the primitives on this side of the pyramid. If I come over to this second example here, then we have a similar scenario with a simple geometric form which is composed from a high resolution mesh. And this is the kind of thing that you typically get with a 3D scan model. In this case, it's much harder to select these primitives using the box selection technique, which we can see if I just disable the Select by Normal mode. And now I'll try and box select the primitives on one of the sides of this icosahedron. It's really not that easy to orbit my view to allow me to cleanly select only the primitives on a single side. This mesh isn't composed of ordered loops and rings of primitives either, so that technique of selecting the primitives around the border of a single side and then flood filling isn't going to work either. But just like before, all the primitives on each face share the same normal direction. So we can use the Select by Normal mode to easily select all the primitives on a single side. So I'll enable the Select by Normal mode again, and I'll click on one of these primitives. But this time we see that we select every single primitive on the object, rather than just those on a single side. The reason all the primitives have been selected is this default spread angle of 60 degrees. We use this spread angle to set the sensitivity, or the tolerance of the selection. And with this object being an icosahedron, I know that the angle between each of these sides is just under 42 degrees. So if I set the spread angle to a value below 42 degrees, so let's say 30 degrees, and click on one of these primitives again, we see that this time we only select the primitives on this single side. We could set this spread angle right down to 0 in this case, and we see that that gives us exactly the same result because the primitives on each side are all facing in exactly the same direction as each other. We don't need to provide any kind of tolerance. However, if I enable this attribute noise swap, which I have here, and now select one of these primitives again, we see that we only select that individual primitive because each primitive now has a slightly different orientation to its adjacent primitives. If I set the spread angle to something like 15 and select one of these primitives again, we see that we now select every primitive on this specific side of the icosahedron. 15 degrees is smaller than the angle between the sides of the icosahedron, but it's larger than the difference in angle between the individual primitives after they've been deformed by the noise. Now, the Select by Normal tool has a few different modes in which it can operate. Its default behavior is for it to grow the selection from the component that we click on to include the adjacent components which are within the specified spread angle. And I'll just disable this Select by Normal mode for a moment so that I can manually demonstrate what I mean by that. So if we were to click on this primitive here, then the Select by Normal mode will look at all the primitives which are adjacent to this, or in other words, all the primitives which share an edge with it. And it will check if the normal of each of these is within the specified spread angle of the one which I've clicked on. It will then grow that selection to include any of the adjacent primitives which are within the spread angle. It then does the same thing again for these newly selected primitives, except this time it's no longer using the normal of the primitive we clicked on for comparison. Instead, it's comparing the normal of each primitive on the boundary of this selection to each of its adjacent unselected primitives. So for this primitive, it's going to compare its normal with the normal of this primitive because it shares an edge with it. and if the normals are within the specified spread angle of one another, then it will select it. And it will do the same for this primitive because it also shares an edge with it. It will then do the same for this primitive and this primitive. It will compare the normal of each of these with the normal of the adjacent primitives, and if they're within the spread angle, then it will grow the selection to include them. It will keep repeating this process until an adjacent primitive fails this test because its normal falls outside of the specified spread angle, and the selection will stop growing at that point. If I just enable the select by normal mode again, and select the same primitive again, we can see the end result of this process. The selection's grown all the way from the primitive which I clicked on to each adjacent primitive because their normals are within 15 degrees of one another, until they get to this line of edges here. Across these edges, there's a greater difference between the normal of each adjacent primitive than the specified spread angle, and so the selection doesn't get grown any further. If I set the spread angle to just 3 degrees, and click on a few of these different primitives, we see that this time we don't select all the primitives on this side of the icosahedron because some of these primitives have a normal which is different by more than 3 degrees to their adjacent primitives. So in this lesson, we've seen how the default mode of the Select by Normal tool works. It selects a single contiguous area of components, and it does that by growing the selection. It grows it from the component we click on to include each adjacent primitive whose normals are similar to one another. And we define what's considered to be a similar normal using the spread angle.